Recall that one of the ways that we can factor complex trinomials is decomposition. So if we use that method here, we're looking for two numbers that multiply to 2 times -2, which is -22, and add to -9. Those numbers are going to be -11 and +2. Because it's a complex trinomial, meaning that the coefficient leading off is not 1, those numbers don't just go in brackets. That's what 9x or -9x breaks down into. We then factor by grouping and look at the first group and say, what's the common factor for those two? It's 11x. What remains is x minus 1. We look at those two. What's the common factor? It's +2. What remains? X minus 1. We now factor out, or we group the x minus 1 terms. What remains is 11x plus 2. And we factored by decomposition. If we go through the rest, the same thing applies. I'll let you do that example. For this example, there's an extra step. We always look for a common factor first. These are all even numbers, so we can factor out 2. Can we factor out 4? No, doesn't work. So we're going to factor out 2. That 2 goes in front and leaves us with 6x squared minus 19x plus 10. We now treat this trinomial as a complex trinomial, and we look to solve it by decomposition. Two numbers that multiply to 6 times 10, which is 60, and add to -19. When we go through, if they multiply to a positive number and add to a negative, they're both going to be negative. So when we start looking at the multiples, or what multiplies to 60, 4 times 15, and if they're negative times negative gives us positive, and -4 take away 15 more is -19. So that -19x breaks down into -4x and -15x. The 6x squared is still in front, the 10 is still behind. They're still in brackets because we still need that 2. Now if we think about decomposition, we want a common factor from there. They both are multiples of 2, so I can take out 2x. What remains is going to be 3x. -4x divided by 2x is -2. Out of those two, again it leads with a negative, so I'm going to take out a negative number. They're both multiples of 5, so my greatest common factor is -5. -15x divided by -5 is +3x. 10 divided by -5 is -2. These are all in brackets with that 2 in front. Usually now what we would have done with the complex trinomial is group these because they are the same. 3x minus 2. What remains? 2x minus 5. But that 2 in front, the common factor for everything, still stays. And now we have a fully factored trinomial into another expression. The second method that we can try is called crisscross. So we need to express this trinomial, 3x squared plus 7x plus 2, into two binomials. Instead of using decomposition, we're going to use this crisscross method. So first we want to think of all the numbers that multiply to the first term's coefficient. So what multiplies to 3? The answers are 1 times 3. That's our only options. Then we want to think of all the numbers that multiply to the last term. What multiplies to 2? 1 and 2. Those are our only options again. However, we could have the combinations of 1 times 1 or 1 times 2. So we're going to take that pairing and we're going to write it as 1 and 2 and 2 and 1. We only need to do this for either the multiples of the first coefficient or the multiples to the last. Now we're going to circle the ones that we're looking at. And we're going to look. And we're going to think that really these are the possibilities to be the F in our first column. And these are the possibilities that are going to end up being our L's, our last times last, if we were going forward. So now we're going to look and we're going to just multiply. And instead of going straight across, I'm going to crisscross. That's why it's called crisscross. Crisscross applesauce. 1 times 2. That would be the O of our FOIL if we were going forward. And 1 times 2 is 2, and really it's X. I would then look and crisscross and go 3 times 1, and 3 times 1 is 3, and they're X's, and that would be the I in our FOIL. And now the whole point is that we want it to equal 7. And 2 plus 3 is 5 X's, which does not equal 7 X's. So you know what? That column is no good. We didn't find our match there. Now we're going to move on to the other combination, 2 and 1. So not 1 then 2, but 2 then 1. And we're going to do the same thing. One times 2 is 2x. Again, that would be the O. 3, oh, my mistake, 1, see, I'm going to the second column. 1 times 1 would be 1x. And 3 times 2 would be 6x. And that would be the I if we were going forward in FOIL. And 1 plus 6 is 7x's. And we're trying to get to 7x's. So that's good. Sweet. That's where we want it. We want 2, then 1. Which means that in the first bracket, we're going to have 1x plus 2. And in the second bracket, we're going to have 3x plus 1. So this is, now we go straight across for what goes in the brackets. So there's our first bracket, 1x plus 2. And in our second bracket, 3x plus 1. And if we were to go forward and expand to check and FOIL, we have 3x squared. Our outsides would have 1x. Our insides would have 6x's. And our last 2 times 1. And then when we collect like terms, we have 3x squared plus 7x plus 2. 3x squared plus 7x plus 2. Awesome. So we've worked backwards. Now this is just another method. Whether you prefer decomposition or crisscross is up to you. If you've grown up somewhere where this is the norm to show your work, you need to show which column there, final answer. If you're not sure and you want to practice, let's do a few examples together. So I look. First thing I do is I look for all the multiples of 2, or what multiplies to 2. And those options are 1 and 2, and that's it. Now, if I need to multiply to -3, I could have -1 times +3, or I could have +1 times -3. I could also have -3 first and +1. And I could have +3 first and then -1. So that's all my combinations, and there's a lot. And if I do it in my head and I know which combination works, I only need to write it down. But let's go first. And I'll color coordinate. So 1 times 3 is 3x. 2 times -1 is -2, which is 1x. And I'm trying to get to 5. Trying to get to 5. So you know what? That column's no good. 1 times -3 is -3x's. 2 times +1 is +2x's, which is -1x. No good. That column's no good. Don't want it. 1 times +1 is +1. 2 times -3 is -6. Those are x's. And I got -5x. Well, I got the 5, but I got negative. That column right there, no good. If I do my last combination, 1 times -1 is -1x. 2 times 3 is +6x. -1 plus 6 is +5x's. Hey, that works. That's what I'm looking for. There we go. I got it. Which means that I'm going to have in my brackets x plus 3. And in my other bracket, 2x, take away 1. And I'm done. If I could recognize which combination works off the top, then I can do that. If we try a harder one. 8. What multiplies to 8? 1 times 8 or 2 times 4. If I think about 15, I have 1 and 15, and I have 3 and 5. Now to multiply to +15, but to give me negatives, I'm probably looking at -1, -15, -3, and -5. And remember, I need to have the opposite order as well. -5 and -3, -15 and -1. If I start with the first column, 1 times 15, 8 times 1. 1 times -5, 8 times 3. And I start and I keep going that way. If I can recognize what combination will get me to 26, 4 times 15, ooh, already too big. 4 times 5 is 20, 2 times 3 is 6. There we go. So if I think about it, and I say that, ooh, 2 times -3 is -6x's, and 4 times -5 is -20x. When I add those together, that's -26. So that's the column I want. So again, my final answer, 2x times -5 in one bracket, 4x minus 3. Crisscross. If I can recognize the setup, I do it. Third example, first step, check for a common factor. Look at that, they're all multiples of 5. -65x divided by 5, -13, 20 divided by 5, +4. If I look at my combinations, again, I'm going to have 1 and 3. To multiply to 4, I have a negative, so I'm going to get negatives. I'm going to have -1 and -4, or -4, -1, and -2 times -2. If I'm trying to get to -13, 3 times -4 is -12. 1 times -1, -1x, which is -13x's. That's what I'm looking for. So my answer, I still have that 5, that common factor, it doesn't disappear. And I have x minus 4 and 3x minus 1. And now I've factored by crisscross. Decomposition, but crisscross. Whatever method you feel more comfortable with is up to you, and you use that one.